Alright guys, today's goal, the learner will understand polynomials and all the pieces of them. A polynomial is a sum of monomials. Each monomial in a polynomial is called a term. So right here, remember, we've gone over monomials before. One term. Some examples of that: negative 3x, yz. That's negative 3 times x times y times z. That's one term. It doesn't matter how many variables are there. Terms are separated by the addition or subtraction, guys. Or you can also have a constant, negative 8. So there's some examples. Binomial means two terms. So 4x minus 1, those are the two terms of it. Negative p to the third plus p squared, those are two terms of it. 1, 2. See how they're separated by the addition? This one was separated by the subtraction. That means you have the two terms. The third main name that you'll see in these, trinomial, meaning three terms. So you have 4x squared, 6x, negative 1. Those are the terms. Okay? So the exponent, this right here is a key piece. The exponent must be positive in order to be a polynomial. Because if we remember, you have something like this, that means 1 over x squared. X to the negative 2 equals 1 over x squared. That's not considered a polynomial because the variable has to be in the numerator, guys. Okay, those are called rational functions, not polynomials. So let's take a look at the first directions here. It says state whether the expression is a polynomial. If it is, list the terms and classify it. When it says classify it, that means, is it a monomial, binomial, trinomial? And if, let's say, there was one with 5 terms, at that point, we just call it a polynomial. You don't have to get specific. The main, biggest 3 choices you have to classify are monomial, binomial, trinomial. Okay? So I look, state whether the expression is a polynomial. Okay, well, I look up here and read what we copied down. The exponent must be positive in order to be a polynomial. So I see I have some exponents. I have x to the fourth and x to the third. Those are both positive, so yes, it is. So I answered, state whether it's a polynomial, yes. If it is, list the terms. Okay, the terms. Well, one of them is 6x to the fourth. That didn't go very well. Apparently I can't write a 4. There we go, 6x to the fourth. The next term, negative 5x to the third. So now, are we done? No. Again, double check directions before you move. And it says list the terms and classify it. Well, how many terms do we get? 2. So what type is that? It's a binomial. Okay. So go ahead and press pause. Try number 2 and number 3. Save some room. Make sure you're writing in pencil because if you make a mistake, you might want to erase. But go ahead and hit pause. Try 2 and 3 here. Okay, so hopefully you did. If you haven't yet, press pause. So state whether the expression is a polynomial. So I look, m to the third, we're good there. Negative m to the negative 1. I don't like seeing those negatives. And I look up here, the exponent must be positive. So that makes this one real quick. No, it is not a polynomial. So you're done. You don't have to list the terms. You don't have to classify it because it's not a polynomial. So let's look at number 3 here. Negative 3a. Negative 3a, we're good there. 7ab squared, we're good there. And 2. So yeah. So yes, it is. List the terms. Negative 3a, comma, 7ab squared, comma, 2. How many terms? We have 3, so what type is it? Trinomial. Okay, so that's basic introductions, guys. So now, a few more pieces we have to learn. So we understand what a polynomial is and how to classify it now. Now we'll see more what is meant by these pieces, okay? Because this is very important when we get into algebra and beyond, okay? So we really need to understand these. Okay, first thing we need to understand, degree of a term. Degree of a term. The sum of the exponents of its variables. Now, notice how it says of a term, meaning one individual piece of the polynomial. It says the degree of a polynomial is the largest degree of all the terms. So how many possible degrees can a polynomial have? 1. Okay? So let's take a look at the first example here. If I look through all the terms, the first term I have 8x to the 4th. So what's the degree of that term? Well, what's the exponent of that? 4. So the degree of the first term, 4. Negative x. The degree of the second term, remember I've been going over this. If you're struggling, you can fill it in with a 1. So what's the degree of that? 1. Now there's no variable there. We've talked about this. That degree is 0 because I could write that as 1 times x to the 0 power. But what does anything to the 0 power equal? 1. So 1 times 1, still 1. So remember, any constant, the degree is 0. So find the degree of the polynomial. Look back up. The degree of the polynomial is the largest degree of all the terms. Well, what's the largest degree of all the terms? 4. So that is the degree of that polynomial. So go ahead and press pause and just try number 5, guys. Okay? So I'm hoping you did. Now, you don't necessarily have to write down all the degrees, but it's good practice. So the degree of the first term, 4. Degree of the second term, 5. The degree of the third term, 0. What's the highest degree? 5. Now, this is where we need to go back. This is where a lot of students can make some mental mistakes here. Degree of a term, the sum of the exponents of its variables. The sum. What does sum mean? Add. So if I look at the first example here where it says 7CD, well, that's c to the first, d to the first. What's the sum of those two? 2. 4c squared d squared. What's the sum? 2 plus 2? 4. So what's the degree of that one? 4. That's what it means by sum of the exponents of its variables, guys. So take a look at number 7. Press pause. Try to do this one on your own. So hopefully you did. And let's see. If I said to the first, 1 plus 3 is 4. The only thing there is n, so 3. So what's the degree of this one? 4. Okay? Now, there's a big reason that we need to understand how to get the degrees. Because we have to learn how to write these in standard form, which is all based on the degree. So if you do not understand the degrees yet, back up and try to re-watch this to make sure you understand this, because we can't move on until you understand how to find the degree. So standard form. A polynomial is written in standard form if it is simplified and the terms are arranged so the degree of each term decreases or stays the same from left to right. Okay? So step 1, look through. Find the largest degree, 1, 2, and 0. So the largest degree was 2. Now this is where you have to be careful. See how it says minus 4x squared? That means when we go to write this in, the largest degree is 2, and we go to write this in standard form, it's negative 4x squared. Cross it off. What's the largest degree left? The 1 right here, 3x. So it's plus 3x because it's a positive 3x. Cross it off. What's left over? Plus 8. So that is standard form. Now, here, when you see things that need to be distributed, there could be things that have to be simplified. So let's go through this. First thing we got to do, distribute that negative 5. So you get 4a minus 5a to the third plus 5a minus 3. So combine like terms. Well, 4a plus 5a, 9a, minus 5a to the third, minus 3. Now we have simplified it. Now we need to go into standard form. So if we look through, we have a degree of 3 as the highest, so I'll make that first. So we get negative 5a to the third, cross it off. The first degree is left over, and the 9a, cross it off. We're left with negative 3. When you cross them off, it helps you see what you've eliminated, so you see what's left to bring down. So go ahead and press pause, guys. Try to distribute, simplify, and then write it in standard form. Okay? So hopefully you guys did. Distribute the 3 is the first thing I would have done. So you get 12b plus 3b squared minus b squared. Well, see, this one was nice. They lined them up right there. What's 3b squared minus 1b squared? Well, it's 2b squared. Standard form, well, 2 is higher than 1, so the 2 comes first. Positive 12b. So we have all of our answers to go into standard form here. Okay? One more piece. Now, this not difficult here, guys. It says evaluate when x equals 3 and y equals negative 2. So they're giving you values. What does that mean we do? Substitute them in. So the first step, it says negative 2x squared. What did it tell me x equaled? 3. So I substitute in the 3. Plus y to the third. What did it tell me y equaled? Negative 2. Plus 1. Now you just have to finish simplifying this. Order of operations tells me exponents. Well, what's 3 squared? 27. Negative 2 to the third. Now be careful here. This one would have bailed you out whether you remembered parentheses on your calculator or not. So I got to back up. I made a mistake here. 3 squared. Is that 27? Nope. So we erase. Well, since I pressed pause there, we can't erase. So we'll just cross it off. So let's do this again. Negative 2, 3 squared, 9. Plus negative 2 to the third, negative 8. Now, you have to be careful. If you need to use your calculator for this, which you shouldn't, and you don't include the parentheses, it can give you wrong answers. We've gone over that many times. Now let's look. Negative 2 times 9, negative 18. Plus a negative means minus 8 plus 1. Negative 18 minus 8, negative 26 plus 1, negative 25. So evaluating should really be the easiest piece, guys, of all of this, unless you make mental mistakes like I did, which is okay, you just have to catch them. So make sure we know what we're doing here. So here we go. So let's read directions. Rewrite in standard form. Step 1. Classify the polynomial. So remember, monomial, binomial, trinomial, polynomial. And state the degree, then evaluate when x equals 3 and y equals negative 2. So what I've done is I've taken all the steps, plugged it into one problem. Make sure you have all these pieces answered when you come in tomorrow. Have a good day, guys.